Thank you for coming to see me. I'm flattered and awesome to have you all here. So we're going to talk about math for 40 minutes. Okay, that's a total lie. We're not going to talk about math for 40 minutes. But we are going to talk about animation and motion, and we're going to get into the nitty-gritty of the details of the math behind it. So hi, my name's Courtney Hempel. I work at Carbon 5. I'm a partner and a tech lead there. If you're one of those people that love Twitter, love me on Twitter. I would love to meet you guys. If you're not a Twitter person, then you can email me. I am going to briefly talk about motion and really humans' perception of motion and why it's important. Then I'm going to talk about animations in interface design. So this is something that is actually being used more and more, both in sort of the mobile iOS world as well as web interfaces, and so why it's important and how it really helps us to understand what interfaces can do for us and intuit what we need to be doing in an interface. And then I'll go a little bit into the frameworks. Briefly, I'm not going to dive in really deeply, but kind of the trade-offs of each one of them and what situations are good for which frameworks. So that's sort of the general gist of the talk. And really, my objective with this talk is kind of twofold, actually. Part of it is to give people that foundational knowledge of math that backs up animations. And more so for the fact, Christian kind of brought this up in his keynote, knowing kind of the underpinnings of all of those frameworks that are stacked on top of it will allow you, when you run into these situations, to really figure out how you need to fix it and how you need to tweak it to get what you want out of it, and to really be able to play around with animations in JavaScript and CSS in a way that will inform you and allow you to sort of flex and expand that knowledge without diving straight into a framework. The meta purpose for this talk is really kind of bridging that gap between designers and developers. I think that designers have so much power with Adobe After Effects and these motion programs, but then translating that into the web, unless they've got a crazy rock star developer at their side, can be sort of difficult. And they're very different domains. The performance is different. How things interact with one another. They're very different. Desktop versus mobile, very, very different. So having designers sort of have an understanding of the nature of what they could do potentially, actually doing their animations, testing them out, designing them on a browser versus doing it in something like After Effects, I think could be really powerful. And equivalently, I think developers, honestly, by nature, they get animation. I mean, we all move, we all see cartoons, we all sort of know what animation is. Being able to have developers understand a little bit about the basics of animation. So sort of bridging that gap. And on that note, I'm kind of curious who the heck I'm talking to. How many people here are straight up developers, just do development? So it's totally the majority. How many of you are designers, just designers? You feel like you only design. Sweet, that's awesome. Unicorns, whatever, show your horns. People that kind of do both, like you feel like you've got, come on developers, you guys, yeah, thank you, okay. So, I'm traditionally trained as a developer, yet I feel like I actually like being in the interface a little bit and like being able to feel like I can design things. And I think all of us, if you're partnered with a talented designer, you can actually have a lot to say about the way in which things work, the way in which things can be intuitive, the way in which they can feel right or not feel right. So sort of bridging that gap is something that I think is, we don't feel comfortable being like, yeah, I'm a designer, but you do have an eye for design, even if you're a developer. All right, so this is Gertie. This is the character that was created by Winsor McKay. He was one of the first animators at Disney. And Gertie was the prototype, let's say, for Disney's foray into motion animation. So right now we're looking at Gertie, and Gertie's, kind of cute. We don't know a lot about Gertie, but if we put Gertie into motion, slow Wi-Fi, wait for it, wait for it. Wait a little longer for it. Yikes. This is the speaker Wi-Fi, too. All right. So here's our little Friday morning cartoons, everyone. Get your Fruit Loops. All right, so that's Gertie. So let's see if we can close out of that. So Gertie just got a lot more interesting. I mean, that's no Nemo. This is not, DreamWorks or Pixar. But that little bit of motion made Gertie a lot more interesting, a lot more entertaining to us. Backed with music, obviously, it then becomes really fun. So Disney, what they ended up doing was figuring out, all right, if we take each frame of an animation, and we create movement between those frames, and then we just take pictures and stack them on top of each other. And this is a flip book, right? This is your most basic animation, frame by frame. So eventually what they established was this way where they would get their senior designers to come up with keyframes. And then they would have sort of, the grunt work being done by these people called the in-betweeners. So they were the people that would take one keyframe and look at the next one, and they would create all the key animations that would go between those keyframes. Sorry, all the frame animations that would go between those keyframe animations. And that now is done by software. And the interesting thing is if you were to think about a human, they're going to be able to sort of naturally know if Gertie's head should move in a certain way versus another way because they know how naturally that should go. But interestingly enough, math and physics can go a very far way in mimicking those natural movements. So it's kind of what we're going to be talking about today. First off, though, I wanted briefly to go into how animations are being used in interfaces today and why they're important. So animations serve as being cognitive aids. There's a book by Don Norman called The Design of Everyday Things, and in it he talks about affordances. So affordance is this idea of if you look at a chair, you kind of have some knowledge about this chair before you ever even touch it. You can kind of afford a use case for it. You can also afford dynamics about it. If you pick it up from one handle, it's going to swing in a certain way. If you sit down at it, it's going to probably take your weight and you'll not fall over on it. So these are things where physical objects can have affordances. It's a desirable property. And you can actually take this and translate it to user interfaces. And in that case, he calls them either perceived affordances or signifiers. But one example of a signifier is when you have the button on the bottom of the old iOS, and it was a camera, but the camera had little ridges surrounding it, and it was sort of this indication. It was a signifier that you could maybe use that as a button and slide it up and down. And then once you actually did that, it sort of jumped, right? You had a little animation that also signified, oh, there's something underneath there. And when you sort of did a little bit more of a swipe, then you saw that the camera would appear from your lock screen. So these are things where you can train your users, and train's maybe a bad word, but you can educate your users on what you want to have happen in an interface by subtle motions. So that's why motion is powerful, and that's why we can use it as both developers and designers to sort of add information to an interface in a lot of different ways. So humans are actually, interestingly enough, kind of crap at peripheral vision elements. We're really good at seeing motion in the periphery, but we're really bad at seeing color changes in the periphery, or even shape sort of shifts. If it's motion that's moving, we can sort of sense it, but if it's other things, we can kind of do a good job of ignoring it because innately we've just evolved to do that. So an example of using motion in interfaces to allow us to know really what's going on is, I'm sure you guys all know, sort of the Pinterest-style progressive loading. So this is something where, it's a very subtle animation. There's not a lot going on there. But your eyes are drawn to the new content that's coming in. And you're not looking behind you. You kind of get what was past, you get what's future, and your attention is continually being drawn. Additionally, we can give a lot of information. So here's two buttons. They're both pretty similar. One, okay, it's wrong. We totally get that. A lot of information has been translated into us. This one, sort of, not that we know a lot more about it, but sort of the playfulness of it and sort of that mimicking of the shaking of a head, it allows us to honestly be a little bit more familiar with the interface at this point. So really subtle things can actually do a lot for our interfaces. I mean, that button takes like 0.2 seconds to create in CSS, and it adds so much to someone's experience of what you're presenting to them. So another thing is that our ability to see navigation and to understand sort of the map of a landscape is definitely tethered to animation. If you can see today when you've got menus that slide in from the left, slide in from the right, slide top, bottom, when you're seeing these things happen, if something slides in and out, you sort of have this map of the environment in which you can manipulate things. And you know that this menu is sort of existing on the side, and there's a map to it on the side. So parallax scrolling, probably overused at this point, but to great effect. We don't have to wait for loading of pages. If you're jumping between portions of that scrolling page, it's really jarring. You kind of get what's happening, but at the same time, you're taken somewhere and you're not really ready to go, or you don't really know where you're going and what the context is. If you do a very subtle animation to that, this is what scrolling parallax does, is you now have an understanding of exactly where things live on the page. And you can sort of take control at that point. You can scroll back to the About section, you know what's going on. Another thing is progressive disclosure. We don't really want to know all the information. We want to know the information that's relevant to us. So we can do a lot with animation to sort of progressively disclose things to people in a manner in which is very fun, it's very easy, we're sort of getting guided through it. We can kind of become, again, more familiar with an interface. So really simple animations can go a long way to have us be using interfaces in a way where we don't have to read a bunch of content about how we need to use the interface. We can kind of be guided through it. So I mean, this is sort of an example from ages ago, but Twitter was the first one to come up with this like scroll to refresh. Really nice to not have to hit a button to refresh things. It's, people were so happy to have this. And it did a couple things. You knew something was loading, you knew something was coming, we were anticipating, and then you knew where that content was going to go. And if that content didn't show up, you knew that there was no new content to load. So super easy way to tell people a lot of what was happening without needing to change or do a screen refresh or whatever. It was just a small animation and people kind of got it. So this sort of goes back to the thing, how do you communicate animation ideas? If you're a designer, how do you do it in a way? Do you vocalize it? Do you present something that's a movie that was done in After Effects? Can you play around with things in a browser? I think that what I'm trying to describe today are ways that you simply can figure out ways to communicate and play around easily in the browser with different ways to animate things that exist on your interface. So we're going to dive now into a little bit of math. So I will absolutely say that I am not a math wizard by any stretch of the imagination. My math skills are probably along the lines of my French skills, which is to say poor. However, even with my minimal set of math skills, I feel like I can do a lot with animation. So I'm going to walk you guys through my simple knowledge of math, and then if anyone asks me a hard question, I'm just going to defer. Okay, so movie in pixels. This is back to sort of the Disney-style animation, frame by frame by frame. We're just taking, really stupidly, this little pill from the left side to the right side. So this totally works, right? This is animation. This is traditional flip-style animation, frame by frame by frame by frame. The only bummer about it is that, okay, it's a little bit boring, that's one thing, but it really only works well when you know sort of exactly where you started, exactly where you want to go, and time has no consideration in this. So if you wanted to extend this, if you wanted to get really sophisticated with this, using just this formula, just this sort of iteration over frames, you're going to have a hard time, right? There's no room in this function for you to do anything cool. So what we want to do is cool stuff. And the basic foundation of that is this linear interpolation function. So it's really actually quite simple. And if you look at it, you can kind of even break it down pretty well. What we're trying to get with interpolation is a mapping. And it's mapping everything that you're thinking about with animation to some number between 0 and 1. So you want to know that there's time that's going to happen, kind of percent complete between 0 and 1. There's also going to be whatever it is that you're animating, whatever percent it is through that animation. So trying to get everything to get between the 0 and 1, it does a lot of things. It gives you a lot of power, right? Between 0 and 1, you can then start to do a lot of powerful things with easing functions with that number. Additionally, if you think about it, if you take a number between 0 and 1, and you take another number between 0 and 1, and you multiply them together, you still get a number between 0 and 1. So this ends up allowing you to use a lot of math and a lot of physics to do some really cool animations. So what I'm trying to get is for everyone to think about things in terms of really percentages, percent complete, percent done. And really, the beginning of this equation, that end minus the start, if you start at 0 and you end at 900, this equation becomes even more simple. I mean, you really, at that point in time, you have your end and then your percent complete. So this equation is actually very simplistic, and we're just going to look at that time divided by duration. That's the really interesting bit. And that's where we can start to create some fun stuff. So this is an identical animation that we've already seen. So now all we're looking at, though, is that we have context of time. We have context of percent complete. We could swap out pixels for opacity or shape changes or whatever it is. So all of a sudden now we have the capability of getting a little bit more powerful with this function. So this is still interpolation. It's just linear interpolation. It's consistent, unvarying progress from 0 to 1. So what we want to do is add some variety into this, because nothing in our world actually moves linearly. So this is kind of a fun quote that I love. This is one of the physicists that was on the Manhattan Project, but he was one of the, I guess, forefathers of the nonlinear science movement. And he has this great term, which is, or quote, using a term like nonlinear science is like referring to the bulk of zoology as the study of non-elephant animals. So this is really the idea that we live in a very natural world. We live in a world that is just seeped in physics and math, and whether or not we sort of see that visually, we feel that very intrinsically, and we're going to respond in kind. So natural movement is something that we find very comforting. You know, if we drop a ball on the floor, it sort of has this like bounce, squeeze, stretch effect. If we roll it across the floor, we expect it not to come directly to a stop, and if it did, we'd freak out probably and run out of the room and be like, what the heck just happened? So we sort of expect things to act in a way, and when you're designing for interfaces and when you're thinking about animations, you have to sort of consider those things too. If you stop something too abruptly, you've maybe lost all your users. So thinking about things in that term is something that can be really powerful. And this is where easing functions come in. So in this function, we are still really going from 0 to 1. All we're doing is going from 0 to run in a very different rate. So at some point in time here, our rate is going to vary more quickly than at another time. And this is where the power comes in to sort of make the movements, make the animations that you have on your screens feel more natural. So the easing functions are really kind of what I was saying before. You're getting them the time over duration, your 0 to 1 number. This is where you insert your easing functions. This is where you start to get to manipulate things. The rate at which you're going from 0 to 1 is what matters. You're still going to start at 0, you're still going to go to 1, but it's the rate at which you're doing so. So the easiest easing function, if I don't repeat myself there, is the power function. So this is, you know, we all sort of went and did, you know, multiply one thing times itself, and that is to a power of 2, right? So it's really easy to conceive of these easing functions in terms of power functions, because all you're doing is that you're rapidly accelerating something. You're exponentially increasing the rate at which something is being attained, right? So it's going from 0 to 1, but it's going to go from 0 to 1 quicker and quicker as the animation gets applied. So this is sort of the Ferrari effect. And again, not the most exciting of animations in this world, but it does allow you to see we're now getting something that feels a little bit more interesting to us. Easing out is something that you see a little bit more used in interfaces, and part of this is you kind of have things slide in and naturally stop. So this is very much, if you've ever heard of Disney's 12 principles of animation design, one of them is this. It's the idea that things that move from your peripheral vision into your center plane of field, they start at velocity. So you're expecting things actually, when they come in from your peripheral visions, to actually move really, really quickly, and then as they reach sort of your center vision, they're going to slow down. So this is just the easing function that we saw before. It's just to a power, but you're just inversing it. So it's starting really fast, and then it slows down. So again, really simple function. The math here is pretty straightforward. You've just got, you know, your percent change here, time over duration, and you're just exponentially increasing it, and then you're inversing it to get the ease out. So let's think about trigonometry a little bit. Not something that I love, but really powerful in the world of animation. This is when subtlety really becomes important. So again, you know, if you have the Ferrari effect and something's moving at lightning speed, very, very different than if you have something that feels like it's eased in quite naturally and you're just like, oh, look, it's arrived. So this is where when you're doing lots of animations on a page, that effect doesn't seem like it changed that much, but if you've got a lot of things moving around, the way in which they interplay is where you can have things feel a little bit more organic or feel a little bit more jarring. So this is where you can start to get trigonometry in to make your easing functions feel a little bit more natural. So I was talking a lot about 0 to 1. We want everything between 0 and 1. Keep your stuff 0 to 1. Okay, total lie. You can actually get things outside of that bracket of 0 to 1. And when you do that, it's called follow-through, also called elasticity. So this is an animation technique when you want to have something kind of go beyond its final resting point and then snap back into place. So it's definitely kind of a fun effect. It's, you know, the rubber band effect. It's something that we absolutely see in the real world quite often, and it's something that people absolutely use in interfaces. So what you're trying to do here is introduce a function to where you can kind of have something, have a little playful snap effect. So this is the elasticity function. And just a reminder, all of these functions are available in a ton of different frameworks. So if you need to know the actual function for the ease or whatever it is that you want to do, they're very easy to look up, and all you have to do is remember you're just swapping whatever that function is in here. So I will fully admit that, the basic underlying tenets of this function and what's happening, I don't dive into that, right? But I know that I can go look up elasticity function, and I can plug it into here, and I can play with it. And I can play with the numbers that are relevant, right? So S is just sort of a multiplier times this power function, right? The K value is the time divided by duration, so that's our percent complete. And I can tweak around those to make sure that whatever animation I'm getting here, sort of that bounce effect, is the bounce effect I want. Do I want it to go faster? Do I want it to go slower? That S number is the one that I can tweak. So playing around with this stuff allows you to just let yourself have more knowledge about what the heck is going on. So you can look up these functions, you can plug them in, and you can play with them. And it'll give you the foundational knowledge to where you can be like, okay, I get it, now I can move on to using frameworks. But then when your framework's not doing what you want, it's going to let you dive in deeper and make those changes that you want to change. So the last one I'll go around is bounce. Bounce is fun. It's a lot better than blink. We see it used a lot, and it is way more fun and just kind of a little bit of playfulness for an interface. So again, this easing function all of a sudden got kind of gnarly. If you start to walk through it, you realize mathematically it's not that big. It's almost saying, if it's in this value, do this, have it kind of bounce when it hits this value. So you can understand these functions pretty implicitly, and then once again, you can change the numbers as you want to. So tweak them to get the exact animation that you want to use. So all of these things are really fun. However, putting them all together is where it really gets interesting. So this is an animation that was done by one of the developers at Carbon 5. He has 2 little girls. So for fun at night, he'll sit down and he'll create just straight up HTML pages with some nutty animations. And in order to do this one, he actually went through this kind of fun exercise that he was describing to us. He filmed his hand moving around a screen, or moving around in front of the video camera, and he was trying to mimic sort of the pattern of a bird. And what he was doing was he would take that video and he would sort of like pretend like his hand was a bird, and then he would stop the video frame by frame by frame. And what he was doing was he was trying to figure out which functions, which easings he could use to mimic how birds would sort of react. And so then he ended up creating this animation based on these specific customized easing functions to have sort of this dynamicness of, what do the birds do when they kind of stop? They don't stop suddenly, obviously. What happens when they all hit the wire together? What happens when they're close to one another? Do they, sort of what does that animation look? So anyhow, this is where you can get kind of powerful in animations and playing around with them. And this is Alex Cruikshank. He's one of the developers at Carbon 5. So finally, I wanted to talk about tools. I just went through kind of how you can do this pretty simply with some simple functions. However, to get really complex, oftentimes you do want to resort to tools. You don't want to really custom roll your own parallax scrolling. That would be such a pain in the ass. There's no reason to do it. That's a solved paradigm. So I wanted to talk a bit about the tools, which ones are worth it, not which ones are worth it, but the specific situations in which some of these tool sets can be used and what the trade-offs are. So now that you guys know sort of what's happening under the hood, you can also dive into these frameworks and sort of investigate them a little bit more. So software is something I've never used. It's used often by the designers that I work with. These are the ones that I've seen and heard them use. That's a total lie. I totally use Keynote, but not for animation. Anyhow, these are great. They're incredibly powerful. You can do nutty animations with them. They're really performant animations. Translating animations from this sort of domain onto the web, and even more so onto mobile, way, way trickier. So it's really, if you want to do animations for something that's going to be, a game design or something along those lines, starting at this point and then doing the translation might make sense. Doing something that's a really simple kind of natural, inspection of a user interface, it might make more sense to actually start in the browser. So if you're going to start in the browser, one place to start are some of these JavaScript frameworks. So Framer.js and Tween.js, both are really good at doing pretty simple animations. Another one that is based off GreenSock. GreenSock has a lot to do with some of the parallax frameworks that you've probably seen. GSAP is their sort of punch at doing animations and overall sort of just JavaScript interactions. It's pretty powerful because it's pretty performant. It's about 20 times as performant as jQuery. jQuery I throw in there because it's something that people use a ton. jQuery is definitely not the most performant if you're doing a ton of animations. And when I say a ton, I mean literally like you're spinning hundreds of balls out at your user, in an animated way at a time. That's where you're going to see performance constraints. If you're doing something like just moving a div in, jQuery Animate is going to be just fine. So definitely before you start to bag on one framework over another, just consider what it is that you're doing. If you're already using jQuery and you just need an animation, use jQuery. If you need really performant animations that are going to be moving multiple elements at a time and that are going to have interactivity, then I think GSAP's maybe a better idea. So CSS is awesome now. I mean, being able to play around with animations with CSS is fantastic. You have to do a lot less straight up coding, but you still have to understand what keyframes are and what some of these Bezier curves and what some of these trig functions are. So animate.css is a great one. A lot of the Sass and less libraries have plugins. The thing that CSS gets you that is really powerful is performance. So something that gets brought up a lot and argued about a lot is the whole JS versus CSS, which is more performant. And I think that the answer is, once again, it kind of depends on what you want to use them for. CSS is fantastic if you want to do an animation that is based in something like scale, rotation, opacity. So it's basically a transform. That is where CSS can actually take your animation and it can elevate it to its own layer that's going to be powered by the GPU. So it's sort of its own thread, it's separate. That's really performant, and it's something that the browsers do really well. So if you're sort of working within that realm and you don't need a lot of sophisticated interactivity, CSS is a great thing to use. And CSS3, being able to play around with it in like CodePen or something like that, is super simple. You can do quite powerful animations. If you want to couple that with a lot of other things that are happening on your interface, then perhaps jQuery might help. There is actually a way in jQuery that you can harness that GPU optimization, and it's using Transform 3D or Matrix 3D. So there is still a potential to use the GPU optimization of browsers in JavaScript. So if you are already tethered to JavaScript, then that's sort of one option that you have. So would love to see you guys all go forth and try out the animation. I think you all sort of have an eye for design. You all have a sense of what interfaces could do. So playing around with this a little bit, just opening up an HTML page using animate.css, or even using some of those functions that I was describing. It's amazing how far you can get with just a little, and now that you want to jump into frameworks, it's going to give you much more of a capacity to understand what the foundational layers are with those frameworks. So here's some references. One of them, Robert Penner has this great page that really walks you through all of the easing functions. Not only does it walk you through them, but it also gives you examples of each one of those. Tween.js, if you dive into the code, you can just cut and paste a ton of easing functions from that and start to play around with them and tweak them. In addition, I highly recommend, if you're a developer, starting to just get an eye for what does it mean to kind of think about design and animation. Don Norman has a great book called The Design of Everyday Things, and in it he's talking about physical objects, but he's talking quite often about sort of humans' perceptions of the way that things move, the way that things kind of feel, sort of that idea of affordances and signifiers. Additionally, Google has come out with the Google Material Design Handbook. Has anyone heard of this? Yeah, okay. Really awesome sort of resource to go to. And in it, they talk very much about animation. And they reference in it sort of the Disney's 12 basic principles of animation. So there's a lot to be considered that. There's thinking about squash and stretch and bounce and movement in and out of screens. Reading up a little bit on that will have you feel a lot more empowered as a developer to actually have a voice as a designer in the room. There's a lot that you can do and play around with given the knowledge that you have in code, and having that be sort of bounced off designers can be really powerful. Another one I would recommend, Smashing Magazine's got a couple really neat UX articles. One is a new mobile UX design material, and it kind of goes through animations like this. Another one sort of references Saturday morning cartoons and how animations from Saturday morning cartoons can be taken and put into the idea of designing interfaces. And then finally, I just have a link in here for Birds on a Wire. So I will put all of this up on the internet and host it. And if you have any questions, I can take them now.